Welcome to The Explainer. Today, we're going to look at the incredible forces that build the very architecture of our planet. Seriously, from the smallest hill to the most massive mountain range, there's a story written in stone. You just have to know how to read it. So let's just start with a really big question. We all see these majestic, crumpled mountain ranges, right? But we also know that the sedimentary rock they're made of was originally laid down in perfectly flat horizontal layers. So how do you get from flat to that? Well, the answer lies deep inside the Earth. It's a story about these immense pressures we call tectonic forces. They're constantly, and I mean constantly, pushing, pulling, and twisting our planet's crust. These forces, which are powered by the incredible heat in Earth's core, are pretty much the master builders of our world. Okay, so these colossal forces can basically be broken down into three main types. And these three are the engine behind literally every geological structure we see. Understanding them is, step one in learning the language of the rocks. Think of it like this. Compressive forces, well, they squeeze. It's like pushing the ends of a rug together. Tensional forces stretch things out, kind of like pulling on a piece of taffy. And then you have shearing forces, which just slide things past each other, like when you slide your hands in opposite directions on a deck of cards. So the big question is, what happens when a rock is under this much stress? It doesn't just sit there, that's for sure. It deforms. But how it deforms is where things get interesting. It all depends on stuff like the temperature, the pressure around it, and what kind of rock it is in the first place. Ultimately, it really just comes down to two basic outcomes. The rock can either bend, geologists call this plastic deformation, or it can break, which we call brittle deformation. This bend or break idea is absolutely crucial. Because when a rock bends, you get a fold, and when it breaks, you get a fault. So let's talk about that first response. What happens when rocks decide to bend instead of break? This is how some of the most spectacular landscapes on the entire planet are made. They form what we call folds. It's just like when you push a piece of cloth from both sides and it buckles. Rock layers do the exact same thing. They crumple into these amazing wave-like shapes. This is that ductile or plastic response of the Earth's crust to all that pressure. And this shows the two main types of folds perfectly. On the left, you've got an anticline, which arches up kind of like a capital A. And on the right is a syncline, which sinks down into a trough. Now, here's a little pro tip for geologists. If you imagine the top of that anticline getting worn away by erosion, the oldest rock layers would be exposed right in the middle. For the syncline, it's the total opposite. The youngest rocks are tucked away safely in its core. And the scale of these things, it's just astounding. I mean, they can be these tiny, microscopic wrinkles in a rock you could hold in your hand,